Now, in this module, we shall able to learn about what is the importance of density measurements, what are the prerequisites for density measurements, and in the end, what are the actual different methods of measuring the density of the glass which is under consideration. Now, this may be either by direct methods or comparison, which we will actually study in this module. Now, actually as we know that different kinds of glass, they have got different physical properties, which actually makes it possible to distinguish one glass from the another. Now, forensic investigators can actually use glass fragments as an important evidence to help solving a crime. Glass is nothing but a hard, brittle substance which is made up of silicon oxides, sodas and other oxides. Now, these metal oxides which are found in most window glasses, they are of sodium, calcium, magnesium, aluminium, while automobile headlights and other heat resistant glasses such as Pyrex, which are actually used in the laboratories also, it contains boron oxides. Now, forensic scientists, they use the physical properties of the glass to associate actually one glass fragment with other, that is, whether they have the same origin or not. So, density is one of these very important physical properties. How do you define density? Now, density is nothing but it is defined as mass per unit volume. Now, we know that different types of glasses, they will contain different combinations of metal oxides. Now, since they contain different combinations of metal oxide, they will obviously have different densities. Now, density measurement is actually one of the very important analysis for comparing the glass samples under investigation. Now, the comparison of densities can give a proof of a connection, if at all, between a suspect and the crime scene. Now, if the density of a glass specimen and the other under consideration do not match, then obviously it can be proved that they do not share the same common origin, or in other words, a same common source. But if the densities match and prove the origin or the source to be common, then it becomes very easy and actually feasible for the forensic people to actually trace the type of glass which has been used or which has been broken when the crime had taken place. In other words, it can actually trace the type of glass that has been used by the criminal to conduct the crime and can be helpful in leading the forensic experts to the suspect. Now, density, which is a fundamental property of glass, actually varies with changes in composition and thermal history. But although density, which is a fundamental property of the glass, whether it is determined by direct methods or by comparison, this determination is considered only if the elemental analysis is actually not available. It is actually impractical to measure density on glass fragments which are very minute, that is almost less than even 2 millimeters. Now, if two samples of glass, they can be differentiated by density. They could have not originated possibly from the same source. Further, limited discrimination may be possible by doing a density comparison in conjunction with the refractive index comparison. Now, density may be used as a screening technique where large number of larger fragments are encountered. Now, this may be particularly useful in identifying now the multiple sources present in the known and in the questioned samples. Nowadays, density measurements are actually very rarely performed in forensic laboratories since they have mostly been replaced by so-called refractive index measurements, which actually provide a similar information with the advantage of being very fast, more accurate and more precise. Now, density of glass can be determined using the sink float method. The determination of density has the disadvantage of involving some toxic liquids and requiring at least 5 milligram of the sample. Another limitation of that density measurements is the measurement of small, irregular or dirty fragments of glass which may be inaccurate.
Importance and use of density measurements. Density can be actually useful to help knowing the composition of the glass sample. It is defined as mass per unit volume of the sample. Density, being an intensive property, does not depend upon the size of the sample. In other words, it remains the same regardless of the fact whether the sample is big or small. But it depends on the changes in the composition and is measured directly or by comparison. This measurement is used only if elemental analysis is not available. Density measurements should be done for samples more than 2 to 3 mm in size. These measurements are useful in identifying multiple sources present in the sample. Prerequisite for density measurements. Proper sample preparation is a prerequisite for obtaining reliable results. Density measurements are not appropriate for fragments of glass that contain inclusions or cracks, or when comparing a surface fragment to a bulk fragment. The cracks in the glass sample can make the glass appear less dense than it really is. The variability of the known sample should be determined when possible. An effort to sample the known glass may include breaking a fragment of tempered glass and including fragments from the bulk and surface to compare to the unknown. Density measurement and comparison between known samples and the suspected samples should be done using fragments of equal size. Sample should be clean and ready. Cleaning may be accomplished in a number of ways, such as rinsing with laboratory grade detergent solution, followed by several rinses of deionized water in order to remove dust and dirt. The samples must be dried following cleaning. Since window glass does not have a uniform density, so care must be taken to determine the variation in density of the known sample from different locations. Also, the surface of the tempered glass is less dense than its interior. So, one has to be careful in taking measurements of several known samples. Different methods for density measurements. These glass fragments under criminal investigations are very small, and so the density of such fragments can be determined either by flotation method or density gradient method. Both the methods are based on the fact that the glass fragments will float in a liquid medium having density greater than that of the fragment, while they will sink in a liquid medium having density less than the fragments. But they remain suspended in a liquid whose density is same as that of the fragments. These methods are so accurate that they can distinguish glass particles that differ in density by 0.001 gram per cc. For the heavier liquid, bromoform or methylene iodide is used. For lighter liquid, xylene, bromobenzene, benzene, nitrobenzene is used. Heavier liquids. Bromoform, chemical symbol CHBr3. It is brominated organic solvent and pale yellow liquid at room temperature. It has high refractive index, very high density 2.89 gram per cc, and a sweet odor like chloroform. Methylene iodide, also called iodomethane. This is a chemical compound with symbol CH3I. It has high density 2.28 gram per cc, is colorless and volatile liquid. Lighter liquids. Xylene, chemical symbol C8H10. Xylene or dimethylbenzene is an aromatic hydrocarbon mixture containing a benzene ring with two methyl groups at various substituted positions. It has a low density of 0.864 gram per milliliter. Benzene, chemical symbol C6H6. It is an important organic compound. Each molecule is composed of 6 carbon atoms joined in a ring with one hydrogen atom attached to each carbon atom. Its density is low, 0.876 gram per cc. Nitrobenzene, chemical symbol C6H5NO2. It is water insoluble pale yellow oil with almond like odor with density 1.20 gram per cc. It freezes to give greenish yellow crystals. Bromobenzene, chemical symbol C6H5Br. It is an aryl halide formed by electrophilic aromatic substitution of benzene using bromine. It is a clear, colorless, or pale yellow liquid with density 1.5 gram per cc. Flotation method. The method involves suspending glass fragments in a density solution within a constant temperature bath. If two or more fragments are suspended, their densities are the same. The numeric density value is not determined in this method but can be determined using the absolute density determination method. The crime and control glass piece, the one with known density samples, are crushed to comparable size with similar shape, which is one of the most important steps. Each piece of glass is briefly sketched and marked for reference. A clean and dry sample of crime glass particle, which is again an important precaution, is placed in a small beaker containing bromoform. The glass will float on the liquid surface, indicating that the density of the liquid is greater than that of the glass. The less dense liquid, xylene, is then added slowly, dropwise, with stirring until the particle is exactly suspended. One should be careful while adding the mixture that it should be stirred with each addition so that air bubbles, if any, are removed. Added similar size, clean and dry sample of control glass. If both the crime and the control glass particle remain suspended in the liquid, then their densities are equal to each other and to that of the liquid mixture. Particles with different densities will either sink or float depending upon whether they are denser or less dense than the liquid medium. The densities of the particles of the glass can be determined by calculating the density of the flotation mixture using density meter. A portion of the flotation mixture is transferred directly to the density meter and the density is thus recorded. Density gradient method. Density gradient method is a good method for examining the glass fragments when there are a number of glass fragments, that is several unknown samples or several possible sources. The method involves placing in a vertical glass tube a liquid containing a gradient of density. The gradient is such that the density at any level is less than that at any lower level in the tube and greater than that of any level higher in the tube. When glass fragments are introduced to the column, each will become suspended in the liquid at the level that is the same density as that glass fragment. Fragments of different density will settle to different levels in this column. In this method, a vertical glass tube about 5 mm in internal diameter and 10 to 18 inches long is sealed at one end and filled with successive layers of liquid in decreasing density. In other words, the gradient is such that the density at any level is less than that of any level lower in the tube and greater than that of any level higher in the tube. The standard gradient tube is made up of layers of two liquid mixed in varying proportions so that each layer has a different density. When completed, a density gradient tube usually has 6 to 10 layers. In this experiment, one can not only compare glass particles but also calibrate the density column. The first layer is the heavier of the two miscible liquids selected. For example, bromoform is heavier while bromobenzene is the lighter one. The second layer is the mixture of 3 parts of heavy liquid and 1 part of the light liquid. The third layer consists of equal proportion of both the liquids. The fourth layer consists of 1 part of the heavier liquid while 3 parts of the lighter one. The fifth layer consists of light liquid only. The layers are added on each other carefully with the help of a pipette to avoid mixture at the interface. The topmost layer and the last layer are taken in such a way that it is about 1/4 to the height of the column, while the second, third, and fourth layers are almost about half of the height of the first layer. The last or the top layer is of the same height as the first layer. Care should be taken to keep the gradient tube overnight so that liquids diffuse into each other to form a gradient. The glass fragments should be carefully and gently placed in the tube and allowed to settle down. These fragments will suspend in the portion having same density. Thus, the density of the liquid and hence of the fragments can be determined. Use. The fragment should be properly documented prior to their addition into the density gradient column so as to facilitate identification when they are recovered from the gradient. The fragments to be compared are gently placed in the density gradient and allowed to settle completely. The position of the glass in the column may be better viewed using back illumination. Care should be taken to avoid changes in the temperature of the column. The density of various glass and related materials are flat window glass 2.47 to 2.56, headlight glass 2.47 to 2.63, mica 2.6 to 3.2, quartz 2.65, flint glass 2.9 to 5.9, diamond 3.01 to 5.2.
Let us now summarize what we have actually studied in this module. We have studied that different kinds of glass may have got different, why may have they have different types of physical characteristics which actually allow us to distinguish them from one another. Now, forensic scientists use the physical properties of the glass to associate one type of glass fragment with another. Density, which is a fundamental property of the glass, it varies with changes in the composition and thermal history. Density can actually be useful in knowing the composition of the glass sample. Now, density measurements for very tiny glass fragments can help us to gain knowledge about the fragments under investigation. Now, density being an intensive property does not depend on the size of the sample. Now, density can be measured majorly by two methods. One is the flotation method and the other is the density gradient method. Both the methods are actually based on the fact that the glass fragments will float in a liquid medium having density greater than that of the fragments, while they will sink in the liquid medium which has got density less than the density of the fragments. Now, density gradient method is actually very good method for examining the glass fragments when there are a large number of glass fragments, that is, several unknown samples or multiple possible sources. Now, these measurements can help in knowing the source of the glass which is used by the criminal and can force the investigators to trace the criminal if possible.